Okay, so for problem number 4, an elevator is rising at a constant velocity. It is not touching the elevator shaft. Okay, so let's draw our elevator shaft first. And now let's draw our elevator. Okay, and I know that there's cords that actually are externally attached that will provide it the lift. So, this being our diagram right now, what are the forces acting on the object? First of all, what is the downwards force acting on the object? You should know that by now. Okay, and well, the object is moving upwards, so we obviously know that there is an upwards force acting on the object. And what's the force that's actually pulling the object upwards? I would actually say that you could say that that's the tension force, being that we're dealing with a cord over here. You could also even argue that it's an applied force. And I would say that either one of these two is correct. I could actually say, hey, you know what, being that the elevator is being pulled upwards, you could say that there's that there's an applied force there. Or you could also even say, hey, you know what, not only is there an applied force, but there's also a tension force acting in the same direction. So we could actually do that. We could say that there's an applied force acting upwards as well as a tension force acting upwards as well. Okay. And are there any other forces acting on this object? Are there any forces acting left and right? Well, no, nothing's thankfully pushing the object, the elevator to the left or to the right at all. You would have a lot of scraping. And it says here that the elevator is not touching the elevator shaft. Let's say it was. Let's say that we actually bring our elevator shaft closer in and that there is a rubbing going on there. Thankfully, that's not going to be the case in the elevators that we ride in. But what if there is? Well, what other force would you actually say would be present if the entire ride up, the elevator itself, is rubbing against the walls of the elevator shaft? Well, I would say that there would be a friction going on. And now, so being that there's a friction occurring over here, which direction is the friction acting in? Well, we know that the elevator is moving upwards, right? And what does friction do? Does it help the object's motion or does it oppose the object's motion? It opposes it, right? So that being the case, I would actually argue that, hey, you know what? The force of friction is acting downwards on this object. And being that it's moving, what would you say it is? Would you say that's kinetic friction or static friction? I would say it's kinetic friction. Now, once again, I actually made this problem a lot more complex than it really should be. What we could actually do here is this. We could get rid of this. I know it didn't say that anything about friction at all. And even at this stage where we're actually just dealing with free body diagrams for the first time really working with them, we could actually either say, once again, it's an applied force or tension force. I really don't care at this stage. We could just say it's an applied force, being that's kind of pulling the elevator upwards. And this is our free body diagram.